Now we have collisions. So the collision manager is in control of running the test commands for everything. So we have the type, the static const type ID undefined. That's just a, okay, if it's not defined for some reason, it's going to be -1. But we have get type ID, which basically says, okay, so this is your unique ID. So the first time someone registers, their ID is going to be 0. And then the next time a different object registers, it'll be 1. And if that same object comes back, it'll still be 1. So it's just a way to have IDs for every type of group that's registering. Speaking of groups, we have a vector of collidable groups. And these are just the user-defined groups that they want to check for. So, oh, I want to check between a bullet and an enemy. So they have a group. We will have a collidable group for bullets, and we will have a collidable group for enemies when they register that. Then we have a list of collision test commands, and these will be run every time process collisions is called, and just check for collisions between the registered groups. So in order to register for a group, they need to call set collision pair or set collision self. We get the two groups needed. Get type via the get type ID function that we discussed just now. We create a new collision command, and we push it back into the test commands we have. And something similar happens with here. We just only have one collidable group instead of two. Moving into the CPP, you can see that, yep, whenever we process collisions, we go through our test commands and call execute on them all, and that will just make them test for all collisions between the two groups. And when we delete the collision manager, we delete all of our collidable groups and our collidable test commands. So the collidable group, just fairly straightforward. It has a list of all collidables registered to it. It has register and deregister again. And we have a get collider list, which will be used by the test commands in order to get all of the objects. You can see straightforward. So let's move into the commands, which is under collision commands. So the dispatch command, the base, is fairly straightforward. We have process callbacks, and then we just say, okay, so we have process callbacks, which says, okay, take in the two types, cast them down, and then call collision on them if they collide. Fairly straightforward. The base, it just has a virtual function, so all of them have to override it. Collision test base, execute is a 0. So moving into the actual commands, we have test pair command. Execute is overridden. We have the two groups that we're testing for. And then we have our dispatch command, which we just looked at. So within the execute, we get the collider list from both of them so that we can look at all the objects. Two iterators so that we can move through them. And we just go through both of the groups, get their spheres, and then we use our dragon math to see if they intersect. And if they do, then we call dispatch process callbacks, and we have the visualizer commands here. Later on, these will likely be moved so that the user can decide if they want to see the B-sphere or not. But for now, we have it so that the visualizer will turn red if the collision is happening and blue if it's not. Also should be noted that the sphere won't always show red during the play, because if you have multiple enemies, only one of them will turn the corresponding sphere red, which is a little annoying, but it's a bug. So for now, it just shows it most of the time as blue. And then we have our test self command, which works similarly, except we only have one group. So going in, we get the collider list, then we have two iterators, and we go through. It's important to note that we have the inner set to the next of the outer, so that we don't have an object testing against itself for collision. Then we, again, test for intersections, process callbacks. and then delete at the end. Fairly straightforward, and that's all of the collision test commands. The scene, how it handles this, is it mostly just passes through the functions. You can see set collision pair, we just call the collision manager's set collision pair. Same for the self. So the scene mostly just has pass-through functions. It doesn't really do much on its own.